Hello, hello everyone. My name is Sachin G. Kumar. I have completed MA English and currently I am pursuing master's degree program in Artificial Intelligence at the Sangalada Computer Center and Prakyan AI and DS School. Today I am going to discuss about machine learning and its classification model case study and other basic things. This is my case study topic, Telco customer churn prediction using machine learning classification model. Its introduction. Customer churn prediction is a virtual process in business analytics where companies analyze customer behavior to predict whether a customer is likely to stop using their service. The churn prediction models use historical data such as customer transactions, demographics, and engagement patterns to identify at-risk customers. By leveraging machine learning techniques, businesses can proactively retain customers, improve customer satisfaction, and optimize revenue. Churn is a critical metric for businesses, especially in industries like telecommunications, banking, e-commerce, subscription-based services, and SaaS companies. Losing customers can lead to significant revenue loss and increased customer acquisitions costs. As acquiring a new customer is often more expensive than retaining an existing one. By identifying potential churners early, businesses can implement targeted interventions like personalized discounts, loyalty programs, improved customer service, and engagement strategies to increase customer lifetime values. Here, the churn prediction is not just about reducing customer loss, but also about enhancing the overall customer experience and fostering long-term relationships. The problem statements used and these objectives. Next, we discuss about the advantages and disadvantages of customer churn predictions. First one improves customer retentions. The second one enhances revenue growth. The third one better marketing strategies. The fourth one data-driven decision making. Fifth one optimizes customer support. And sixth one competitive advantages. And the disadvantages are first one data quality issues. Second one high computational costs. Third one privacy concerns. And fourth one false prediction. And fifth one implementation challenges. These are the models we use in this case study. First one, random forest classifier. Here it is an ensemble of decision trees that improves accuracy and reduces overfitting. Next, we use decision tree. It's a simple tree-based model that splits data based on future data conditions. The next, that is gradient boosting. It's a boosting techniques that builds models sequentially to correct previous errors. And next, XGBoost. It is an optimized gradient boosting library known for speed and performance. Conclusion. Customer churn prediction is an essential tool for businesses looking to improve customer retention and optimize revenue. By analyzing customer behavior, transaction history, and engagement patterns, businesses can identify customers likely to leave and take proactive measures to retain them. This case study highlights the importance of data-driven insights in understanding churn patterns and developing targeted retention strategies. Key factors such as customer service interactions, contract duration, and pricing influence customer decisions, and addressing these factors can significantly improve retention rates. While churn prediction has its challenges, such as data quality issues and evolving customer preferences, its successful implementation provides business with a competitive advantage. By leveraging predictive analytics, companies can enhance customer satisfaction, reduce revenue loss, and foster long-term growth. Moving forward, businesses can further refine their churn prediction strategies by incorporating real-time analytics, customer sentiment analysis, and personalized engagement initiatives to strengthen customer relationship and improve overall business performance. Next, we discuss about the case study. This is a case study heading. This is the dataset we used. Here it is an Excel file. Here we discuss about the dataset. The telecom customer churn dataset contains only 7043 records and 33 columns, providing detailed information about customers, their demographics, subscription details, billing history, and churn status. Here, the key features include customer tenure, monthly charges, contract type, internet and phone service details, and whether they have additional services like online security, tech support, or streaming options. The dataset also contains churn-related variables such as the churn level, churn score, and churn reason. Although the latter has many missing values, a notable issue is that the total charges column is stored as an object instead of a numerical values, requiring conversion for proper analysis. To gain insights and exploratory data analysis, the EDA can reveal patterns in churn behavior, such as the impact of contract types, payment methods, and tenure on customer retention. Additionally, machine learning models like logistic regression and random forest can be applied to predict churn and identify key factors influencing customer decisions. Cleaning the dataset, handling missing values, and performing future engineering will be essential steps building predictive models. These are the key observations from datasets, data types, categorical variables, and numerical variables. And these are the potential issues. And next, we import the libraries using NumPy, Pandas, Matplotlib, Seaborn, TensorSplit, Standard Scaler, 114 order, 11 order, these models. First of all, we discuss about the libraries and its purposes. Here, importing pandas as PD, its purposes is used for data manipulation and analysis. The examples are reading dataset, handling missing values, and performing data transformation. Second one, that is NumPy, import NumPy as NP. Its purposes is to provide support for large multi-dimensional arrays and numerical computations. The examples are array operations, mathematical computations, and handling missing values. And next, we import the Matplotlib Hyperclass PLT. Its purpose is used for creating static, animated, and interactive plots. Example, line plots, histogram, scatter plot, and etc. And we import the Seaborn SSNS. Its purpose is built on top of Matplotlib. It provides statistical data visualizations. Examples are heat map, correlation matrices, and box plots. And next, we import the trainer split. Its purpose is to split the dataset into training and testing sets. And next, we import a standard scaler. Its purpose is to standardize features by removing the mean and scaling to unit variances. And next, we import the one-hot encoder. Its purpose is to convert categorical variables into numerical format using one-hot encoding. Next, we import the label encoder. Its purpose is encodes categorical variables as integers. And next, we import the classification models and a forest and gate boosting. Here, firstly, we install the OpenPy Excel. Here, Pandas requires these to handle Excel files. And next, we load the dataset using these codes. Here, it is an Excel file. And then we print the first 5 rows of the dataset using these enter functions. And we find the information using this info function. It's the information we get. And we'll check the shape also. So the dataset is shape. Here, using the describer function, it provides summary statistics of data frames, numerical columns. It helps in understanding the distributions and tendency and variability of numerical data. We count the mean, standard deviation, minimum, Q1, Q2, Q3, maximum, and print the column names of this dataset using these codes. And we drop the irrelevant columns like lat long, zip code, country, state, city, churn level, churn reason using these functions. Drop function. And then we handle missing values using these functions. Here we check in missing values exist and we convert the total charges into numeric for handling errors and, and using this median to fill the missing values and then we drop any remaining rows with missing values using this drop function and we print the missing values after cleaning. This is the before and after cleaning missing values. And then using label encoder, this code identifies categorical columns in dataset by selecting columns with the object data type. It then applies label encoder to convert these categorical columns into numeric format. After encoding the first few rows of the dataset, data frame are displayed using df.headof function. Oops. And then we apply the one hot encoding using this function. Here, this code applies one hot encoding to categorical variables using period.get dummies of these techniques converts categorical columns in get underscore calls into numerical format by creating separate binary columns for each category. The parameter drop underscore first equal to true removes the first category from each encoded column to prevent the dummy variable trap, which helps avoid redundancy in regression models. Next, we remove the outliers. Here, this code identifies categorical columns in data set by selecting columns with the object data type. It then applies, sorry, this code defines that the function removes outliers from the specified numerical columns in the data frame df. The outliers are detected using the interquarter range IQR method, where values outside the range of Q1 minus 1.5 into IQR and Q3 plus 1.5 into IQR are considered outliers. After applying the function, it prints the shape of the original and cleaner datasets. This is original and cleaner datasets. There is no variations. And next, we create a box plot for before and after removing outliers. This is a box plot. Here, this code creates side-by-side box plot to compare data distributions before and after outliers removal. The left plot shows the original dataset, and while the right plot displays the clean dataset, helping visualize the impact of removing outliers. Here, there is no outliers removed, so there is no references in these plots. And next, EDA, we create a count plot. Here, the count plot visualization provides insights into the distribution of churned and non-churned customers with the dataset by plotting the churn value column using Seaborn's count plot function. Here we can observe the frequency of customers who have either stayed at is 0 or left that is 1, 0 or 1. The use of the rocket color palette enhances visual appeal, while the inclusion of labels and annotations ensures clarity in interpretation. This analysis helps in understanding the imbalance in churn distribution, which is crucial for model development and business decision making. Adding value labels on the bars for the improves. Further improves readability, making it easier to grasp the insight at a glance. Next, we create a histogram plot using these codes. So the histogram visualization provides a comprehensive overview of the distribution of numerical features in the dataset by plotting each numerical column separately. Here we can identify patterns such as skewness, outliers, and central tendencies using the Debbins ensures a detailed representation of the data distribution, while edge coloring enhances clarity. A well-structured layout prevents overlapping plots, making interpretation easier. This analysis is crucial for understanding future variability, detecting potential data imbalance, and informing pre-processing steps such as normalization or transformation. Overall, these visualization numerical features distributions help in making data-driven decisions for model development and optimization. Next, we create a box plot using these codes for monthly charges and total charges. Here, the box plot visualizations helps in identifying the distribution and presence of outliers in the monthly charges and total charges features. By using Seaborn's box photo, we can observe key statistical measures such as the median, quartiles, and potential outliers. The monthly charges box plot displays in orange provides insights into the availability of customer payments, while the total charges box plot shows in blue highlights the overall spending patterns of customers. These visualizations are essential for detecting anomalies, understanding data dispersion, and etc. Next, we discuss about the future and target. Here, this code defines a future matrix that is x by dropping the target variable churn value from the data frame and assigns the target variable y as the churn value and prints both shapes also. So x shapes. The next, train the split, extend extend by test. Next. Next, using standard scaler, this code scales the training and test data test future data using standard scaler to standardize the future by removing the mean and scaling to unit variance. And next, we using the classification model. First, we use random forest classifier. Here we import the evaluation matrices. Then we initialize the random forest classifier using these codes, and we train the model, extend scale and by train, and we make predictions on the test set, hybrid, and we evaluate the models using accuracy, precision, recall, and FN score, and we print the scores, and we display the confusion matrices also. And next, we using decision tree classifier, the same steps. And next, gradient boosting classifier. Last, that is XGB classifiers. We are using these codes to compare the model performance, the random forest, decision tree, gradient boosting, and XGBoost, and its accuracy, precision, recall, and FN scores. This is models and its evaluation matrices scores. And then we visualize the model performance using these plots. Here the first plot is based on the precision comparison, second plot based on the recall, and the third plot based on the FN score. This is a accuracy, precision, and recall and FN score. And we print the model performance comparisons using these codes. This is the result we get here. Using these codes, the best model based on the performance matrices is gradient boosting because it has the highest accuracy, precision, and recall and FN scores. Since FN score balances both precision and recall, The gradient boosting is the optimal choice for predicting in this case. Next, the conclusion. In this Telco customer churn prediction case study, we aimed it to build a model that could predict customer churn based on demographic, account, and service user data. After performing data pre-processing steps, including handling missing values, encoding categorical variables, and removing outliers, we explored the dataset to understand the distribution of churn and the key factors influencing it. We trained several machine learning models like including random forest, decision tree, identity boosting, and HCB boost, and evaluates their performance based on accuracy, precision, recall, and reference score. Among these, the gradient boosting classifier emerged as the best model, demonstrating the highest balance between precision and recall, making it the most reliable for predicting churn. The insights from the model highlights the importance of focusing on factors like monthly charges and service usage patterns to reduce churn. Ultimately, the findings suggest that the company can leverage the gradient boosting model to proactively identify customers at risk of leaving and implement targeted retention strategies, ultimately improving customer loyalty and business performance. And next, conclusion. Here, if you want to know more about this, here this is my GitHub link. It also has other similar case studies and its YouTube explanation video. Thank you. Hello, sir. Sir.